Good morning, friends. So, in today's video, we are delivering the concept on open set and the closed set. So, let us understand that what is open set and closed set. In the previous video, we have discussed the neighborhood of a point, and the concept of neighborhood will play an important role for imparting the concept of this open set and the closed set. So, now in this video, we are just discussing what is open set. Dear friends, please understand that when we are discussing this open set or closed set, we are just discussing that everything has to be a subset of real line. Everything has to be a subset of real line, because you have to consider the subset. So now let R be the set of real numbers. Now I consider let S be any subset of R. Be a subset of R. I will say that S is said to be open, said to be an open set if S is a neighborhood of each of its points. Now see, if S is a neighborhood of each of its points means if X belongs to S be any element, then it should imply, now we will consider the neighborhood of X, that is X must belongs to X minus epsilon comma X plus epsilon, and it must contained in S. So we can say that then it is a neighborhood of each of its points. Now the next question arises. I can say that my example 1 is every open interval is an open set. Every open interval is an open set. The reasoning is very simple, because if I consider any open interval, you can say that if there is a point X belongs to open interval, this will imply my X is strictly greater than A and less than B. Now if I consider the neighborhood of this point, now this is interval A, B, and there is a point X. Now it is the neighborhood of it, X minus epsilon and X plus epsilon, where X is any point. So you can clearly see from the diagram, now X belongs to X minus epsilon and X plus epsilon, where epsilon is very small, which is clearly contained in the open interval. So you can say that, easily say that this open interval is an open set. But I can say that closed interval is not an open set. Please try to understand that. Closed interval is not an open set. What is the reasoning behind it? Because closed interval AB is not a neighborhood of each of its points. Because this closed interval AB is not a neighborhood of each of it means, because it is not a neighborhood of the end points A and B. That is why, because the definition itself is saying that it has to be a neighborhood of every point. The reason is because closed interval AB is not a neighborhood of A and B. So we can say that, now see, any finite set of natural numbers, whole numbers, integers, rationals, they are not an open set. Even phi is not an open set, are not open, because they are not neighborhood of each of its points. I can say that set R, that is a real number, is a neighborhood of each of its points. So therefore R is an open set. R is an open set. Now the concept comes, that is, what is closed set? What do you mean by closed set? Now let us considering what do you mean by closed set. Let us understand it. We can say that if S is a subset of R, S is said to be closed set if its complement, that is its complement, that is S dash, which is equal to R minus S, is open set. Now see, now it becomes really interesting. Try to understand it, because this concept will play a very important role. So now I can say that number one, now set natural number n is a closed set. Why? Because its complement, that is equal to R minus n, is a neighborhood of each of its points. Neighborhood of each of its points. Now, how it is possible it is a neighborhood of each of its points? Try to understand it. Because what you will do here, when you are taking the complement, because you are just removing the discrete part, that is 1, 2, 3, these parts are removed. Now if you take any point, if x belongs to R minus n, definitely x is not a natural number, then you can say that any interval x minus epsilon, x plus epsilon, and x belongs to it, it always contained in R minus n. It always happen. So I can say that from here, n, z, phi, and phi, and any finite set are closed set, because their complements are open, because their complements are open set. That you can verify by using the definition. So friends, you have to keep the definition in your mind while applying these concepts. Now let us consider a few more examples on the closed set. Every finite set, and now the next question is set of rational numbers is a closed set? Answer is no. This question may be asked because now see, what is q complement? This is R minus q, and that is turning out to be irrational numbers. And now suppose if you are tried to develop its neighborhood, because you are going to write x minus epsilon and x plus epsilon, and you are considering x belongs to this and x also belongs to R minus q. It will certainly not contained in R minus q, because this interval will contain rational as well as irrational number. It will contain rational as well as irrational number. So therefore you can say that q is not an closed set. So q is not an open as well as closed set. Q is not a closed set. So these are elementary concept I'm just discussing with you. So there is no harm, you can say that. Now the next question arises, can we say that a closed interval, now if I take any closed interval, suppose I consider in closed interval 2, 3. Now what is its complement? When you are going to find its complement, here is 2 and here is 3. So you are finding its complement, that is you are removing this particular part. It is turning out to be minus infinity, comma 2 union 3, comma infinity. And please note down that it is open and it is also open, and union of open set is open. So therefore closed interval is a closed set. Closed interval is a closed set. Now the next question arises, what you can say about open interval? It may not be a closed set. If I take open interval 2, 3, it is not a closed set. The reason is because when I take its complement, which is turning out to be minus infinity to union 3 to infinity, so you can say that it is not open because it is not a neighborhood of 2, and it is also not open because it is not a neighborhood of 3. So you can say that open interval need not be a closed set. So open interval need not be a closed set. Now my question is there any set which is both open as well as closed? Set which is both open and closed. But obvious, it is a set R because its complement R dash, that is equal to R minus R is phi. And which is both open as well as closed. Now see that. Now we have given the enough examples on this, and now let us consider a set which is neither open nor closed. Can you give an example of a set which is neither open nor closed? Neither open nor closed. That is equal to any semi-open interval. You can take any semi-open interval. So you can clearly mention here so we have given, and please note down that we are just making one correction here, and the correction is phi is open. So we are removing why phi is open. Phi is open because there is no element in phi for which it is not a neighborhood. Phi is open because since there is no element in phi for which it is not a neighborhood of that point. Okay, so friends, we have just recorded the lecture on open and closed set, so please go through it carefully. So take care. Bye everyone.